Okay, so this video picks up where the last video went mute. Sorry about that. I've got one last example for us. This one is like number 2 on the worksheet. And so let's go ahead and do that. It says, given the XY coordinates of a point are 3, -4, find 2 different R theta coordinates such that, and then it gives some conditions. And it wants 1 to be where R is positive and 1 to be where R is negative. And so what they're asking for is actually 2 answers for each part. So I've got 3 parts, 3 sets of conditions, and so that will give us a total of 6 answers. So this is actually a flashback to some problems we did about a week or so ago. And so this is mostly review, but I'll talk you through it as it has been a little while. So we're converting rectangular to polar, and the book outlined several steps in order to make that happen. Their first suggestion was to draw a picture of just a little sketch, 3, -4, so I'm going to go over 3, down 4, so it's going to be somewhere here in the 4th quadrant. And that sketch just kind of helps keep us oriented, and it should just help us be able to answer the rest of the question if we know which quadrant we're in or which quadrant we're trying to get to or whatnot. So I'm going to put a 3 here along x, -4, and so our theta is right here. Okay, so we could use that picture to help us find r first. So remember, we can do that just with the Pythagorean theorem since we have a right angle. So I can do 3 squared plus -4 squared is r squared. And so this is actually our pretty common 3, 4, 5 triangle. So 9 and 16 makes 25 for r squared. And so r will be 5 or -5. And again, if you go back to the directions, it wants us to give an answer 1 where r is 5 and 1 where r is -5. And so we've actually found half of our answer for all of these. So again, we'll have a coordinate. R comes first. We'll have 5 something for one of these answers, and then we'll have 1 coordinate with -5 something. We'll just leave that something blank right now. And then we're going to have the same thing for the other 2. Is this one's going to have a coordinate with 5, and it will have 1 with -5 for r as well. And then one more time, we'll have the same for this one, 5 and -5. Okay, so now we need to find angles that work for each of these conditions. And so there's 2 ways you can find the angle. Sometimes it's obvious. It's, you look at your triangle and you're like, oh, I recognize that one from the unit circle. If not, though, we do have a backup plan. And this one I don't think is obvious. 3, 4 isn't a ratio that I might know off the top of my head. So remember, we can use tangent to help us out. We know the tangent of that angle is y over x. And so that would be -4 thirds. And so then we can do the inverse tangent of -4 thirds to find an angle for theta. And so I'm going to give an answer in radians. All the answers that I provide for this number 2 in the worksheet are going to be in radians. So I would recommend that you stick with radians too. And we get -0.93. Okay, well, so that means, if I start at 0, I'm going backwards 0.93 radians to get to this angle. And if we look at that value and look at part A here, you will notice that -0.93 radians is not between 0 and 2 pi. So I'm not going to use this angle for either spot here. However, it might actually make sense to start with B because this angle does fit between -pi and pi. And so I think that's the answer that I can put with the positive r. I can put 0, -0.93 radians. Because if I go backwards, 0.93 radians, and then if r is positive, I'm going to go forward in this direction, and that's where I want to go to get to that coordinate. And so the value that your calculator gives should be the value that goes with part B, and a positive 5. Now, since we're on part B, let's go ahead and answer this part here. So now we want to know what angle would allow r to be -5. And so when r is negative, remember we just travel backwards along that radian. And so we ultimately still want to land here though. And so the radian that we're going to be looking for is going to be the one that's directly across, opposite of -0.93 radians. And so to get directly across or opposite of, we're just going to add, we're going to go halfway around the unit circle. And so if I'm sticking with radians, I'm going to add pi to get to that spot. And so if I want to know what this value is down here, I'm just going to take -0.93 and add pi. And if I do that, I should get about 2.21 radians. And 2.21 is between -pi and pi. So pi is 3.14, so that's a little bit less than that still. And so that checks out. It looks like it's in the proper range. So I'm feeling pretty good about part B now. So why don't we backtrack to part A and see if we can come up with some answers here. Notice here it says we want, we're going to do the same thing. We want one coordinate where r is +5, one where r is -5. But this time we want the angle to be between 0 and 2 pi. And you might notice that the range here actually overlaps with part of the range here. 0 to 2 pi, well, the 0 to pi of that 0 to 2 pi range is actually included when we look at -pi to pi. And so what that means is this angle that we found down here should double over as an answer that we could use here for part A, shouldn't it? If we do 2.21, so that's a little bit less than pi, right? And that's greater than 0, so that fits perfectly between 0 and 2 pi. So I don't see any reason why we can't just reuse that answer that we found over here. So that was again found by taking -0.93 that we found in our calculator that pointed this direction and adding pi. Now we cannot use this value here in this space because this one is negative and it clearly shows that we want something greater than 0 and less than 2 pi. And so we do, however, want to be pointing in this direction, though, because r is +5. So if r is +5, we need to land going this direction. And so what if we start with -0.93 and instead of adding pi, we just add one complete revolution? And so we just need to add another pi to that. Is that right? So another half a revolution to get here. So that would be another pi, at least from this spot, right? If we're starting from the original, I'd be adding 2 pi. And so to get that value, we're going to take that -0.93 that our calculator gave us and add pi twice, or be easier just to add 2 pi. So when you do that, you get about 5.35 radians is the answer I got. And that checks out okay. 6.28 is going to be about 2 pi, so this is a little bit less than that still. So it looks like we're in the right spot. Okay, so now we're ready over here. We're almost done. We want angles between 2 pi and 4 pi. So just keep in mind that if r is positive, we want our angle to be pointing this direction. If r is negative, we need to be going this direction so that we count backwards and land in this same spot right here. So I think all that means is that really we just need to keep going forward, right? If these values are between 0 and 2 pi, couldn't I add 2 pi to this one that we found here, and that would just take me one revolution around, and that would be greater than 2 pi but less than 4 pi. Or if you want to think of it, you can start with your original -9.3, and instead of going one full revolution, we're going to have to go 2 full revolutions. And so instead of adding pi or 2 pi, we'll add 4 pi. Does that make sense? So again, that starts me off here going backwards where the calculator suggests I am. Go forward, that's 2 pi. If I go all the way around again, that's another 2 pi, so 4 pi total. And that gives me a value of 11.64. And 4 times pi, 4 times 3 is 12, so 11.64 is a little bit less than that even, and so that checks out and should be in the proper range. And then for this one, we want to be landing this direction. And so if we go back to the answer that we had here where we added 2 pi, so again, we start here, go forward 1 whole revolution, and that brought us to 5.35 radians. Well, to get over here and be passed beyond 2 pi, we want to go forward another pi. And so that would be a total of 3 pi, is that right? So 1 revolution is 2 pi, another half of a revolution would be a total of 3 pi. So again, if we take that original calculator answer of negative 0.93 and add 3 pi, that should give us an answer that we can put in here. So I got 8.49 radians. So we'll slide that in there. Now you might be wondering, what if instead, what if I, when I got my 11.64 radians, so that was going around twice, what if instead of only going 3 pi around, what if I kept going to 5 pi? Well, that would certainly land in the right place, but the problem would be is I think we would be past 4 pi at that point. Okay, 2 whole revolutions is 4 pi, so if I go again, that's going to be 5 revolutions, and that's going to be too far. It's going to go way beyond, maybe not way beyond, but it'll go certainly past 4 pi, which is over here, right? So as soon as we go beyond the x-axis or the polar axis there, that's going to be too far. All right, so anyways, you have a question that's kind of like this on your worksheet. It's number 2. It has a different coordinate, but at least it gives you kind of the idea of how to get started. So here's your homework one last time. Part of it's in the book. So again, these are the 2 where you're going to graph 2 together and see where they intersect. And then if you could go ahead and do some algebra to confirm that the point that you're looking at is in fact the right point. And I want to see that exact point too. Sometimes on the graph you can tell an exact point, but a lot of times you can't tell exactly what the r and theta values are. And so use some algebra to help you find those exact coordinates. And then the next group of 3, those are the ones where they give you a graph and you're going to write an equation. You're going to have to find A and B to do that. And then 92 is kind of a standalone question where it just has you think about what it means to be a function and whether our definition for function for rectangular coordinates holds up for polar coordinates. So I'll let you think about that one. And then on the worksheet, number 2, of course, is the one similar to this. Number 3 is a really good question. It's probably maybe the most challenging one. It talks about, it gives you 2 different polar equations, and it wants you to graph them and just explain any similarities and differences. And so I would recommend, I think I give you a hint on that worksheet, but I would recommend that you use your graphing calculator for that. And there's a table button that can be really helpful. I think that hint is also given on there. So to graph on your calculator and then use your table. And so let me show you what that looks like real quick. So I still have the graph that I did on the last lesson on my calculator. And so, you know, you could type those equations in, graph them. That can help you see what the graph looks like pretty quickly. But to be able to note differences, I would encourage you to use the table feature, and that's the second key right here. So if you just hit the second button in the graph, it'll bring up some values on your table, and so that's going to be a clue to helping you answer that question well. And so I think I want to just leave that hint like that. So take a look at those values in the 2 tables. You'll have an R1 and an R2, and I think, again, that'll provide a clue. If you get stuck on that, you know, I do have the answers provided, so maybe you could read a little bit of that to see where we're getting at with those. I tried to be very detailed on that question. Again, I'll kind of leave you with, you know, this is an assignment we normally would do together in class, and, you know, you would have a friend to work with or me available to answer questions. So if there's any way for you to, work with a friend, maybe over video chat or through text or something, that's certainly not a bad idea. Or if you get stuck and you want to talk through some of these with me, please reach out and let me know how I can help. All right, good luck, and thanks for listening.